Hi, it's Paul. In this clip we're going to look at cell groups and work on honing our skills at working out what sort of cell type we're looking at. So here you've got a large group of cells. It looks three-dimensional. There's nuclei overlapping in it. Quite a bit of depth of focus, probably a couple of nuclei deep. We'll look at that under high power. Around the outside of the group, I can see what looks to me like fairly dense cytoplasm. So I'm checking out, first of all, in the middle here, focusing up and down. Yep, a couple of layers of nuclei, but no honeycomb coming into focus. Around the edges, I can't see any columnar shapes like palisading, so I've eliminated endocervical cells. And to me, the cells around the outside look squamous. So they have a central nucleus and dense cytoplasm. This group's a bit easier, I think. It's a bit of a slightly folded sheet, but I can bring a good honeycomb into focus. And pretty much every nucleus is in focus at once. I can see a bit of a columnar shape on the left hand about 5 o'clock, and also if I bring it into focus up on the top, endocervical cells. What about this group? It's dense, it's dark, there's an intermediate cell. They look kind of tightly packed, suggesting there's not much cytoplasm, and on high power I can see quite a bit of depth of focus in this. I can't bring a honeycomb pattern into view. I can see some interesting chromatin that might be maybe stippled, like that one. The cells around the outside are not really columnar in shape either, so they have quite a high NC ratio and look more cuboidal than columnar. And then these areas and this area have a darker core to it, and so does that there. So this is like two exodus put together. So I'm thinking these are endometrial cells. Just cruising around, mainly squamous cells, some neutrophils, another group of cells here. What do you think they are? So even at low power I could see most nuclei are in focus, and then I can bring a honeycomb into quite good focus here. So all the nuclei focused at once. This end I can see some columnar shapes, so we've got palisading, maybe a bit of vacuolation there, and definitely a honeycomb pattern through here. I can see the nuclei are quite eccentrically placed, so up one end of the cell around that area, and it's again columnar shaped cells just lying off there. So these are endocervical cells. What about this group? So a bit of depth of focus here and a bit of nuclear overlap, so not that same columnar organisation. Look at the cells around the outside. There's always a valuable information in those, and there's a couple of cells there that look definitely squamoid, and they have the same cytoplasm as the cells pretty much in the group. It's dense, it has a well-defined border to it, and the nuclei are in the centre of the cell. So I'm not seeing any palisading around the outside of this group. So I'm pretty happy these are immature squamous cells in a group, so like atrophy. See down here, there's definitely squamoid cells with central nuclei and an NC ratio that's about right for an immature squamous cell, so either a parabasal or a squamous metaplastic cell. So the features you really need to look at when you're evaluating groups are their cohesion, how well they're holding together, the organisation of the groups, so is there much depth of focus? Are they all in one focal plane? How many nuclei can you focus through? Always look at the edges of the groups. You get a lot of information there about the cell type. So you can look at, is the nucleus centrally placed, or are there columnar shapes and palisading there? Look for the cytoplasmic features. How dense is it? Does it have well-defined borders? And finally, look at the depth of focus in these groups. and the variation in nuclear size and shape, so anisokaryosis. That becomes really important when we're looking at neoplasia, high-grade SIL in particular, which forms quite three-dimensional groups that have quite a bit of depth of focus and, importantly, variation in nuclear size and shape.